Hi, this is the second example of a friction problem, and basically I drew this little clamp here, and I'm sorry if you can't really tell that it's a clamp, but I just wanted to kind of point out a unique situation because we're so used to seeing ground and like a solid surface, and I just want to show you how you can translate it into an easily understood situation, even if there is no ground. So, what is the max F? That's what we want to know. And let's just say that the pressure is resulting in a 500-pound force. Okay? Let's give us a friction factor of 0.7. So knowing these two things, we should be able to figure it out. But I just want to show you how to model something like this. And it's quite simple actually, because what you can look at is you can look at this as you can look at this object right here as solid, or as something that is non-moving. The part that this pin is, that this screw is pushing onto whatever this surface is, onto our object. So what I'm saying is that we can just model it like this. And then you have your box, which, there you go. Then you have your force down, and you have your pressure force right here. This is the same exact situation. And realize that P is equal to 500. Still 500 force. So I just want you to be able to make this leap. If you can do that, you'll save yourself a lot of time and you won't confuse yourself. So knowing that, we got to bring ourselves into the situation. Let's redraw it real quick. And so you have our box, and you have your force pushing at it. So what you're going to have is you're going to have a reaction force, or a normal force or reaction force, right? Then you're going to have your force pulling down. We want to know what the maximum is. Well, the only thing that's going to be resisting that is our friction force. So if we were to just do a simple analysis, sigma f of x must be equal to 0, you can kind of see that just n must equal p, and that equals 500. So that solves some of our problems. Now we know what n is, so we could actually go in and try and find the friction. But let me just solve the y direction real quick. And just with a quick glance at it, you can kind of realize that F will equal the friction force. So this just kind of guides us and says, hey, we need to find out what the friction force is. Friction force is going to be normal times our friction factor, which is equal to 500 pounds times 0.7, which from that you'll find is 350 pounds. And that's the maximum amount of force that you can pull down without making it slip. Once it slips, it's going to go down, and it's going to go down quite a bit. So just one thing I wanted to emphasize, that the biggest step is not the math, not this stuff, but it's all right here. It's trying to get a nice model, trying to get a nice free body diagram. A lot of errors that you make in vector statics will be because you missed something in your free body diagram, or you just drew a bad free body diagram. So one or the other. Anyway, let's just continue on. I think I have one more for you tonight, so I'll see you guys in the next video.